So in this video, we are going to understand the LeetCode problem number. This is very important. So we will first understand what the question is saying in the LeetCode 1871. It's a jump game 7, right? That we will understand. Okay. If you have any doubt, you ask me in the comment section because I'll start from the very beginning. Okay. But still, if you have any doubt, you can ask me. So this problem is called jump game, guys. Jump game 7. The very first, we have to see that what we have given. So we have given, the very first thing is it's a binary string s. Okay. And another thing we have given is two integer. This is what the question saying. Two integers we have. We can say the mean jump, right, and the max jump. So two things we have given. Now it is saying that we should start, right, we start at index 0. So if we'll start from index 0, right, from any index, right, so let's say that we have an array like this, right? So there will be some data is there. We'll not talk about that, this data, but we have index, and this index start from 0, 1, 2, 3, 4, and so on, if the data we have, right, more in the element. So it is saying we start from the index 0. Okay. And from index I, we can jump to any j. So if this is your index I, right, let's suppose we call this index I, and index I start from 0, 1, 2, 3, right? So let's say this is index I. Okay. Or index I can be anything, either 0, 1, 2, 3, 4, right? We can say that. Okay. So it is saying from index I, you can jump to any index j. So these, if I is 0, j can be any of these, right? Either 2, 3, 1, 4, we can say that, right? So from any index I, we can jump to any index j. If we start from I, we can go to any index j, right? This is what the question is saying. Now it is saying that, so we'll say I plus mean jump. So mean jump we have already given, right? It should be less than equal to j. Okay. And the I plus max jump. So this should be the range. I should be less than equal to 1 plus mean jump, and should be less than equal to I plus max jump. Okay. And if we have any element s at j, we can say that s at j, we have some element, let's suppose, for this j. Okay. Means if it's equal to 0, means the s at j should be 0, then only it can be reachable. In that case, guys, what we have to do, we have to return true if we can reach last index. Okay. If we can reach the last index. Okay. If we can reach the last index, we can say. Let me recap you again so you will understand, right? And yeah. So the very first thing is that what it is saying, that in LeetCode 1871 Jump Game 7, we have given a binary string. Then we have given is two integer, that is mean jump and the max jump. So if we'll take any index, let's call this, right? So for we can start, we will always, let's suppose I will be here, or j will be here, right? So we have to start with here. Okay, so the index will start at 0. Okay, so for any index I, right, we can jump to any index j. Okay, and the range for the I as j should be 1 plus mean and 1 plus max, and it should be between. Okay, and if the index at j we have 0, it means it is reachable, so we return true if we can reach the last index, right? It means we have to return true. Now what we should understand, that it's very important to understand the problem here, right? What is the problem? So for every index, guys, for every index, if I is reachable, then all indices is in the range, right? Means it is saying, if you see here, it is saying we start at index 0, right? But for any index I, if I is reachable, then all indices are in the range. What are the ranges? What are the indices? So the ranges start from I plus 1, mean jump, and I plus max jump. So I is reachable for every position I. If I is reachable, then all the indices are in the range between here to here. Okay, so can potentially it become reachable or not? It become possible, right? So for brute force, check for every index, and that will give you your O of n square. And so we should not go with that, because it give you the TLE exception, time limit exception, it will give you, right? So then we should optimize the solution. Either you can use not either, we should use the solution that will give you the DP plus sliding window approach. Okay, so use DP plus sliding window, guys, so it will help you in the optimized solution that will give you the O of n time. Okay, and that we need here for the for the complexity wise. Okay, so how will you solve this problem? Sliding window DP problem is the idea where you should start with. Okay, so let's start from here. Okay, okay, so I'll say that I'm going to use sliding window DP. Sliding window DP. Okay, guys. The very first thing, that let's take DP at I. So DP at I will mark true. Okay. If the index I is reachable, if index I is reachable, we'll keep it DP at I is 0. So for current index, right, let's suppose for current index I, we need to know what we need to know. Is there any reachable index we have, right? Reachable. Okay, you check the spelling. So is there any reachable index in what? We know that I plus mean jump and I plus max jump is the range. So can we re-say that I minus max jump comma I minus mean jump, right? Can we say that? Isn't this question right? Is there any reachable index? Is there any reachable ch? Is there any reachable index in this range? I minus max jump and I minus mean jump, right? So instead of scanning every time, right, we maintain a running count of reachable position inside the valid window, right? So we can find the solution, right? What I'm trying to say, I'm saying instead of scanning every time, we should maintain a running count, right? Okay guys, keep it the notes, right? Running count of reachable position inside the valid window. Okay, so the very first I'll show you how to implement the solution, right? And then we should see how how we'll approach the problem. Okay, and how we should do that. Okay, so let me first show you like what we should do, guys. Okay, so think that we want we don't want the brute force, because from every reachable index we are trying all the possible jumps. That means we do nested loops, right? That will give the complexity of O of n square that we have already talked about, right? So we need the optimization, because that input, there is a we have the large inputs, and for the large input it will fail, right? So we need the optimization, right? So what is the important thing that you should understand is, for every index I, we only care about one thing: is there any reachable index inside a valid range? That range we have seen is I minus max jump, comma I minus min jump. So if at least one index is reachable, exists there, right, then the current index can also become the reachable. So this is the key insights we can say that we have, so we can understand. So very first thing, that you use the dp at I, right? And you need to create the dp, right? So dp at I means it is nothing more, means can we reach to the index I. If we can reach to the index I, we'll mark that index as a true. So for every position, check whether any valid previous position is reachable. If the previous position is reachable, it means the current index is 0. Correct, guys? So here is the here it comes the magic here. So instead of scanning the entire range, right, every time we maintain a sliding window, right? That is called count, right? Sliding window count, we can say, right? That is called reachable. We will use that. This will tell you that how many reachable indices exist inside the window. So we'll just need to check. Let's suppose I'm talking about, if we'll take a reachable, right? So this reachable we will keep only for what? For sliding window. It will store sliding window count. So sliding window count will be there. That is called reachable. So this will say that how many reachable indices exist currently in this window. If the reachable is greater than 0, guys, if this reachable is greater than 0, it means we have the number, then the current index is reachable, right? So this reduces the complexity from O of n square to O of n. This is the huge thing that we should understand. So do not think that this reachable is that we should use is not important. So when you have this reachable count, right, means the sliding window count, we can say that, right? So this will tell us how many reachable indices currently exist in this window. If reachable is greater than 0, it means the current index is reachable, right? We can say that easily, right? So this is what we need to do, and how to implement, let's understand. So before going to the code, right, I'm thinking that let's understand, because this problem becomes sometimes confusing, because it's having a sliding window, a part that feels invisible at the first, right? So what you should understand that give me a second, let me change the pen. Yes. So with the very first thing that we should think about what we have given, right? So let's suppose we'll go with the example. So let's think that we have in example 0 1 1 0 1 0, right? This is what we have given, and it is saying the mean jump we have given is 2, and the max jump we have given is 3, right? So if I'll say about the index, right? For the index is 0 1 2 3 4 and 5. Can we say that? You can represent in the array also, okay? It's fine. So let's suppose that the very first thing is we start from the index where 0, right? Because this is the starting index, right guys? So we start at the index I, right, which is equal to 0, right? So what jumps are allowed? Think about, okay? Let's say sorry, let's say let's say and say what jumps are allowed. Think what jumps are allowed. So we can say that, okay, from any index, from any index, right guys, from any index I, we can jump. Where we can get jump, right? The very first is I plus 2 to I plus 3. So if we can jump from I plus 2 to I plus 3, because the mean jump is 2 and the max jump is 3. This is what we have given, right? So we'll say, okay, let's start with the some steps. So we'll say, okay, start at index 0, right? The very first we'll say, okay, reachable. So reachable, in the reachable we'll put 0 first, because the count is 1 itself, because we start from the 0, right? So now from index 0 we can go where the possible jumps are. We'll say now from index 0 where can we go, right guys? Can we say that? We'll say we have possible jumps that we have, right? Jumps are, the very first is 0 plus 2 will go to 2, 0 plus 3 will go to 3, like that we can say that, right? So we can try index 2 or index 3. So try index 2 or try index 3. Can we say that? But the main thing you have to think that we can only stand on 0, correct? Let's go back here and check what we have at index 2. At index 2 we have is 1, means this is not reachable. So we'll check index 3, it is reachable, right? The very first we was here, so from here we jump, right? We jump to this index, we can't jump, then we have to jump some another index that is here. So index 3 is reachable, okay guys? So we'll say that we have checked, right, index 2, we have checked index 2, which is s at 2 we can say is 1, right guys? So so we can't stand there, right? Can we say that? See, why I'm writing is everybody can understand, right? Sometimes people think that what he is talking, right? That is what guys I'm doing. Okay, the very first thing that we checked index 2 and it we can't stand there means it's not reachable, correct? Now check index 2 and we have seen that s at 3 is nothing but 0, means we can stand there, right? And so this is reachable. So index 2 or index 3, sorry, index, this is index 3 and this is index 2. Okay guys, so we can reach there, means this is reachable. So this time reachable is, previously it was 0, now is 3, correct? So now let's go back to here, right? So now we have to check the next index. So from 3, if we will add 2 jumps, we'll reach to where? At here, at 5. And if we'll add 3, we'll go out of the box of the index, which is here somewhere, but that is not in our index range, so we cannot go there. And for 5 is 0, so we can reach there. So we'll say that, okay, in step 2, we have checked that. In step 1 we have checked, and from there in step 2, yeah, this is step 2. So we'll say from step 2, right, from index 3, sorry, from index 3, where we can go? Now jump from 3. So the possible jumps are, we have seen the possible jumps, 3 plus 2 is 5 and 3 plus 3 is 6. So this is out of index, right? So this is not possible guys, right? And we have seen that here we have is 0, right? So this is possible, so this is possible and this is not possible. Simply I'll say that, right? So simply we'll say, okay, now what is the reachable now? So we'll say reachable is 0, 3 and 5. We can say 6 is not possible, so we'll not go with the 6, right? So the last index we found is reachable, and so we can say the answer will return as a true. So we'll say, okay, we reach the last index, and so answer is true. You will return true answer. Now the important part, this brute force approach idea is easy, but imagine the array, we have thousand crores, right? Lakhs. For every index we have to check all the jumps which is possible, right? But it's expensive, and that's why we have to optimize, right? Correct guys? So we'll say, okay, so can we do something else? Instead of asking can this index jump to somewhere, and we reverse thinking, we ask can someone jump to this index, right? We can say that. So this changes everything, you know. So what we need to do, let's suppose we are checking index 5. I'm saying suppose, oh sorry guys, let me change. Suppose that we are checking index 5 directly, okay? Who can jump to 5? So we'll say the allowed jumps are, so jumps we know that already, which should be less than equal to 2 and less than equal to 3. This is the range, right? So if we want to check that at index 5 who can jump to index 5, So we'll say there is two person who's allowed, or two indices are allowed, right? Allowed jumps are for 2 and 3. So between 2 and 3 jumps are allowed. So the possible previous positions are, right, from the before the index 5 is, we can say, the possible previous position, okay, check the spelling fine, are 5 minus 3, which is equal to 2, and 5 minus 2, which is equal to 3. So either he can jump or either he can jump, meaning only index 2 and 3 can reach to 5, right? So if if we are checking who can jump to here, right, to index 5, so we'll say that there is only two indices, right? Only index 2 or index 3 can reach to the 5. So we check, what we will check, we'll check, okay, is dp at 2 or dp at 3 are true. Make the condition if, right, or is, right, is dp at 2 and dp at 3 are true. If they are true, means, if yes, means index 5 is reachable. Am I correct or not? Right? This is what we want, guys. Okay, so let's understand little bit more so it become more clear to you, right? So let's say for every index, I, we check this window, check this window we check this window. What is the window? Window is I minus max jump, right, comma I minus mean jump, correct? So this is the window we are talking about, right? So let's understand with the example. Okay, so we talked about I equal to 5, right? So what is the window becomes? So we'll say window becomes is 5 minus 3 and 5 minus 2. This is our window, correct? So which is equal to 5 minus 3 is 2 and 5 minus 3 is 2 and 5 minus 2 is 3, correct? So this should be the window. Yeah. So let's say that the initially we have the index 0, 1, 2, 3, 4 and 5. Okay, and this is for the dp, guys. So we'll say the very first, it should be true, right? So we want to check this one, right? But before that, we'll check f here, f here and t here, right, and f here, like this. So we have to check right here. So we check inside the saddle region, let's suppose, and we'll say that okay, at least one should be the true, right, to is this reachable or not. So either this position or this position should be true, at least one should be true. If at least any of the true, so here we found that this is true and this is true. So dp at 5, we can say dp at 5 is equal to true. Understand? So why the sliding window we are doing here? Because without optimization for every index, we can scan the entire range again, right? And that gives you the O of n square. So instead, we maintain a reachable. So reachable means what? How many true values currently exist inside the window, right? So suppose we talked about index 5, right? So suppose current index is 5. So we have checked window is 2, 3, right here. So now we can move to I equal to 6. But the new window become what? 3 and 4, right? So index 2 leaves the window and index 4 enters in the window. This is exactly the sliding window technique is, right? So we have to check the concept here, how we remove the index and how we add the index, right? The simple thing, right? So let me show you the code now, so you are ready to understand now. Oh my gosh, so many things we have talked. Okay, the very first thing that we want to check if reachable is greater than 0, right? The very first which we define, so these are the things that we need to define. The very first, n, how many index we have to go, then dp, the very first index is should be true because it's already standable, we can stand there, means it's reachable. So start with the reachable 0 0, so you start with the mean, right? Go to the n, right? And the very first we know that dp I minus 1, if dp at I minus 1 means now a new index we are entering, right? So that is reachable plus plus will happen. Okay, so when we are leaving the window, right, so we know that I minus max jump minus 1, so reachable is minus minus 1. Okay, like that we will think, right? So the current, let's talk about the current window, right? So reachable is greater than 0, it means what? If the reachable is greater than 0 means at least one reachable index is valid or exist in the valid range. Okay, so in that case we will check the current index. So index s at current is should be equal to 0, it means it will marked as a true, right? So this, the very first you keep checking the reachable, right? If we are entering we will keep doing plus plus, if not we'll do minus minus. Otherwise, you know, if reachable is greater than 0 and it is 0 means dp at I automatically it become is true, right? So the current index always, it can say that it becomes reachable. This is the entire trick, right? And if dp at I minus, the mean jump we will talk about, right? So we are increasing the we are adding a new element which is entering into the window, and for this part, right, we remove the old element which is leaving the window, right? And finally we understand that some previous reachable index exists and the current cell is 0, it means the current index is reachable. So the final intuition we can say that, guys, the whole problem is basically, does the range contain at least one true, and sliding window helps the answer that gives you in O of 1, right? So instead of rescanning the entire range every time, that converts the total complexity of O of n, right? So now the solution becomes much cleaner once you think in terms of who can teach me instead of where can I go, right? So thank you guys. Thank you so much in this video. In case if you have any doubt, let me know in the comment section and we'll go from there. And if you're struggling with the DSA preparation, you can join my online classes. And that's all in this video. Thank you so much. I'll see you in the next one.